Hi students, today we'll be learning about centroid and center of gravity. Hi students, so today we'll be learning about centroid and center of gravity. So over here we have few things which we need to remember. Hi students, so today we'll be learning about centroid and center of gravity. So over here we have few things which we need to remember. Hi students, so today we'll be learning about centroid and center of gravity. So over here we have few things which we need to remember. Hi students, so today we'll be learning about centroid and center of gravity. Two things which you need to remember. Few things which you need to remember. So, this is our x-axis and this is will be our y-axis. Sorry, this is x-axis and this is y-axis. X and y-axis. So whenever we have a component of force which is lying in first quadrant, we represent it as F is equals to supposedly 20 Newton. Over here, this angle which we are representing over here is an anti-clockwise angle, supposingly theta is equals to 20 degrees. So we can resolve this part into two individual components along x-axis, that will be fx is equals to 20 cos of 20 and fy will be equals to over here along y-axis, that is 20 sine of 20 degrees. So whenever we have an angle which it makes with an horizontal or vertical, that component is always a cos component, because if we draw a triangle law over here, if we draw the same vector diagram in terms of triangle law, then we can get the hypotenuse F is equals to, that is equals to 20 Newton. The angle with the horizontal will be equals to theta. So that is theta is equals to 20 degree, and the vertical over here we can draw. So this part is F is equals to 20 cos of 20, and this part Fy is equals to 20 sine of 20 degrees, because we know cos theta over here is opposite upon hypotenuse, and sine theta is equals to This is not cos theta, this is rather sin theta. So now we have been learning this. We can use this in terms of our calculator also. So supposingly we have a calculator over here. Now, if we want to study the calculator in more detail, so we'll go on mode setup over here. So over here 23 into 45, that is 1025. So now we'll use this to study few modes over here. First mode which we need to study is a complex mode. So in complex mode we have 5 plus 3i. We can convert this into r and theta. To understand this part, we will go it over here. So over here we have y-axis and x-axis. So x-axis will keep as a real axis and y-axis will keep this as imaginary axis. So any point in this plane will be represented by p x comma y. So it can be written in the form of complex number, that is a plus ib. So a will be its x coordinate, b will be its y coordinate. So now this complex number p can be represented in terms of complex number that can be written as 5 plus 3i. Similarly, over here, if there is a point Q, that is again x comma y, but here this is x comma minus y, not x comma positive y. So a point Q can be represented as, supposingly x coordinate is 5 minus 3i. So these are complex variables. So we can convert this complex variable from polar form from polar form to rectangular form. Now, how to convert a variable from polar form to rectangular form? So, for that, we need to know few basics of equation of circle. We know equation of circle is x square plus y square is equals to r square, and theta is equals to tan inverse of y by x. So similar to that over here also, we are in rectangular form. From rectangular form, we are going to a polar form. So that means to come to this point all over again, from the origin, you will take a definite amount of radius, that is small r. You will rotate that radius by some angle, that will be theta. So hence you will get over here a small triangle which will consist of its vertical component, its horizontal component, and its hypotenuse component. So its hypotenuse component we consider r. With respect to horizontal axis, we'll consider theta. This is y and x. So we'll get over here x is equals to r cos theta and y is equals to r sin theta, r sine of theta. So we have gone from two forms over here. So let us remember this. That is, we are going from rectangular to polar form. Rectangular means our value will be in terms of x and y, and we have to convert from x and y to r and theta. So how to convert from x and y to r and theta? That is, r is equals to x square plus y square, and mind you this is square, and theta is equals to tan inverse of y by x. The second part which we can see it over here is from polar form to rectangular form. Polar form means what? We have the value of r and theta, and we have to convert from r and theta to x and y. So that means x and y should be on the left hand side, r and theta should be on the right hand side. So over here this will be r cos theta and this is r sin theta. Hence, our complex number over here is a plus bi. So that is 5 plus 3i. So that can be written in terms of polar form, that is a plus bi. We have to convert that for from rectangular form to polar form in r and theta. So technically this will be given as r will be equals to square root of x square plus y square. So that is square root of 5 plus 5 square plus 3 square. So this will give you some value, and theta will be equals to tan inverse of 3 by 5. So these are the values which we will encounter. So let us calculate this value. So we have our scientific calculator over here, and we have the complex number we have typed over here. So we'll press shift and we'll press 2 because complex is written on number 2, and we'll press 3. So once we press 3 and equals to, we'll get the angle as well as theta. Since it is in square root of 34, we'll put from s to d. So s to d will give us over here the value, that is 5.34, and theta was equals to 30.96. So this is 30.96 degrees. So this is what we have got from rectangular to polar form and polar form to rectangular form. Now the second variable over here we need to understand in complex number is the sign convention. So now sign convention in rectangular form we'll study, that is sign convention in rectangular form, and we'll have the same thing, sign convention in polar form. So we'll have our horizontal x-axis and y-axis. Similarly over here, horizontal x-axis and y-axis. So over here we always know that in first quadrant x will be positive and y will be also positive. In second quadrant x will be negative and y will be positive. In third quadrant it will be negative, negative, and this will be positive and negative. Whereas in this part over here, that is, we have r and theta. So r and theta. So over here we know that from this entire polar form definition, this part that is r will be a scalar quantity. It is a scalar quantity, and theta is a vector quantity. So together, this is, let's give its magnitude, and this is given by its direction. So this will give us the direction. So how we can write this? So now, if it is in the first quadrant, theta is in first quadrant over here. This is r and theta. So theta over here will be positive since we are calculating this as anti-clockwise, and theta is less than 90 degree. When theta is less than 90 degree, we all know the angle will be an acute angle. Similarly, on the other side of the equation, what we have over here, once it goes in the second quadrant, this will entirely, the value of theta will be it will be greater than 90 degree, and theta will be again positive. Whereas if we go in the fourth quadrant, then over here theta will be negative and theta is less than 90 degree. And in the third quadrant over here, theta will be negative and theta will be greater than 90 degree. So in short, we can summarize this part as in this format, that if it is an acute angle and it is positive, it will be in first quadrant. Obtuse angle which is greater than 90, still it is positive in the second quadrant. And then we have again an acute angle which is theta is negative. So clockwise we are measuring this as clockwise, this as anti-clockwise. Anti-clockwise angle measurement we considered as positive, and clockwise angle measurement we consider as negative. So over here this will be again an obtuse angle and it is negative. So this is how we divide the sign convention of polar form into four different parts. So next thing we need to study is about center and center of gravity. So for studying for center and center of gravity, we should understand first what is a centroid. Now centroid is defined as geometrical center of the body. So it is geometrical center. Now, what do you mean by a center? That means if we consider a rectangle, so at the center or the intersections of the two diagonals, there will be a point. That point will be called as the centroid. So that is specifically a midpoint of any shape that will be called as the centroid. Next, we'll define is a center of gravity. Now we can define center of gravity, that is a point on a body. Since we have not defined a body yet, we'll define this a point on the body where entire entire weight of the body is concentrated. Weight of the body is concentrated. So so center of gravity will be a point on the body where the weight of the body is supposed to be concentrated. And last we'll have, that is center of mass. Center of mass is a point where entire mass of the body mass of the body is supposed to be concentrated. So these are the three definitions we need to study. That is a center of mass, center of gravity, and centroid. So once we have got into these definitions, we'll proceed further for definitions after definitions, that is centroid of few physical quantities. So to study centroid of few physical quantities, we'll first divide that into few sections. That is, we'll take over here, that is not area. Over here, we'll take that into few sections over here. Pardon my mistake. That first we'll consider the shape of the body. Now shape will be a triangle, rectangle, whatever that may be. Then we'll consider its area, and then we'll consider its x coordinate and a y coordinate. And before learning this, we'll go back to the previous section and we'll study something about area. Area has a relationship between, there is some relationship between area and weight. So let us study what is relationship between area and weight. So first of all, we know that F is equals to mass into acceleration. So weight will be equals to its mass into acceleration due to gravity. So this is the basic definition of force, and this is the basic definition of weight. So weight can be written as m into g, and we know that density is equals to mass upon volume. So volume will be equals to mass into density, mass upon density rather. We can cancel the statement. Mass will be equals to density into volume. So over here we will use this definition and substitute in this equation. So we'll get this as a weight is equals to density into volume into g. So that will be equals to density into area into length into g. So we know that volume is equals to area into length. So best definition of this part is for cylinder. So we know that for a cylinder, it's we can draw this as a cylinder over here. So now we know this top surface area over here. This is area of cross section, that is pi r square, and this entire part is the length. So over here volume will be equals to area into length. So volume will be equals to pi r square into h, which is the area of, which is the volume of this entire part. So on the other side, we will write down over here, weight will be equals to density into area into length into g. So over here we will consider a random body, supposingly of any shape. It will have some amount of its thickness. So this will be its thickness. So we have three assumptions for centroid. That is, a it should have constant density. So density should be constant. So density means constant. We shouldn't have a composite area. We should have a uniform, not composite area. We should have a uniform body or uniform density. Second thing we need to have over here is the length of the body. Length will correspond to the thickness. So the thickness of the body will remain constant. It should remain constant. So that is the second assumption. And the third assumption, that is acceleration due to gravity, is constant. So we are not experimenting this part in space or on moon or under the earth or above the earth at some altitude. We are doing learning the centroid and center of gravity at the sea level. So over here the three quantities are constant. That is, first quantity is density, then we have length as well as acceleration due to gravity. So we can write weight is directly proportional to area. So we can eliminate the use of weight. We can directly write it as directly proportional to area. So over here, we'll go to the next section, which we were talking about the shape, area, and centroid. The first shape will take that will be symmetrical about x-axis as well as y-axis. So this is x-axis, this is y-axis. This will be the breadth of the triangle, rectangle. This will be the length. So area will be equals to length into breadth. So x bar will be equals to L by 2. Y bar is equals to B by 2. That will be at the intersections of the two diagonals. That point will be called as the centroid. So we know what will be the types of centroid. First we'll see that for a triangle over here. Let us consider a triangle that is A, B, C. This is the height of the triangle and this is the base of the triangle. So this is B, this is H. We'll take this elemental strip that will be dy and the length over here will be L. So here we'll name this point as P, this point as Q. So we know that area of triangle ABC is similar to triangle APQ. Then we can write over here that is PQ upon BC is equals to is same as the vertical height over here. Let us consider as A, that is A upon H. So PQ is the length which is L, BC is the length which is B, is equals to A upon H is the vertical length. So L will be equals to A into B upon H. So that is what we have come to. So I'll just write it down over here. That is capital small h, small l is equals to A into B upon H. So we know that x bar is equals to integral of AI into xi upon integral of area. And y bar will be equals to the same part. So over here, x bar will be equals to integral of this small elemental strip will have an area of L into dy, whereas its x into the value of since we'll consider this as rectangle, it will be equals to L by 2 upon integral of L into dy. So we'll substitute the value of L in this equation.